I spent the last 2 months building the ultimate secret door for my home office, solving dozens of mind-bending challenges and pushing my skills to their limits. But to test how secret this door really is, I've been hiding the entire project from my wife. This is the first time she's seeing it, and at the end of the video, we're gonna find out if she can solve the secret lock and open this door. This project started 2 months before the reveal with one of my favorite satisfying woodworking techniques. Right here, I'm using a power carving disc on an angle grinder to create a scalloped pattern in these pieces of Douglas fir. There's just something about this pattern that I love. I've been using it on a bunch of my projects lately, and where I live in Vancouver, British Columbia, a lot of people have solid wood front doors, many of them made from Douglas fir, which has a beautiful, rich color. It's also just an amazing tree native to this part of the world. This is a picture of Eden next to a massive Douglas fir estimated to be over 1,000 years old. So as I was saying, these rich wooden front doors, big inspiration, but obviously this door has a lot more going on. And in case you're new here, I recently built another secret door. That one is for the tiny library on my stairs, and I love this project, especially the super tactile mechanisms. No motors, no microcontrollers, everything's manual, analog, and super satisfying. So I definitely wanted to bring that into this project, but the library door, it was all about hiding the mechanisms and disguising the door as a piece of modern art. But for my office, for this room that's full of 3D printers and tools and possibilities, I wanted to go the complete opposite direction and really highlight the mechanisms, put them on display. And unlike the library, I'm not making a custom size sliding panel to cover this weird hole in the wall. I'm building this door the exact same size as the existing door, 80 by 30 inches. So I can just swap it out, which makes the installation super simple, at least in theory. We'll just go up to outside the garage.
Okay.
Because you can't see what's in the garage.
I know. I'm once again a prisoner in my own home.
And since we rent this house, this is an easy way to customize the space without any permanent modifications, because you know I'm taking this door with me when we move out. Wait, Eden!
I locked him out.
Okay, so like I said, I want a big, satisfying mechanism on display. And ever since I saw this video, I have been obsessed with planetary gears. This one is part of the drive mechanism for an excavator because planetary gear sets allow for huge reductions. In other words, you have to spin the center sun gear many times in order for those outer planetary gears to revolve around the sun gear just once. Now, I'm pretty good at designing stuff, but I am no mechanical engineer. But as I've done more of these projects that are way outside of my comfort zone, I've learned 2 important lessons. Number 1, every mechanism under the sun has already been designed, so you don't need to reinvent the wheel. There are lots of great gear generators out there, like this one that generates full planetary gear sets, vector files, any ratio and size you want. And number 2, the single most important thing to remember when you want to make anything.
Just do it! Make your dreams come true!
Now, I used to think that advice meant that if you really want to do something but it intimidates you, you should just dive right in, full force, ready or not. But I think that's a great way to do bad work and be disappointed with the result. Yes, dive right in, just do it, but start with an experiment where the only goal is to learn something. So while I was cannibalizing these ventilation fans to build into the door, I swear the only reason I get anything done is because I'm procrastinating doing something else. While I was doing that, I started making some cuts on scrap plywood, and before long, I had myself a working planetary gear set. Now this is just a model, but it gave me so much confidence because it's the exact size that I want for the door. You can see that we have 1, 2, 3, 4, 5, 6. 1-to-6 ratio. Now, it didn't give me quite enough confidence to finish the design and actually build the thing, so I continued with my productive procrastination and started making the wooden rings that would hold the fans. These pieces of plywood will become the forms that I'll use to create the wooden rings out of solid Douglas fir. The plan was to have 2 fans at the top of the door, kind of inspired by this picture here. I was so excited for this upgrade. This was going to be so much better than my current solution for getting air into the room when I'm working with chemicals or 3D printing some of the nastier filaments. Also, check out who finally got a miter saw. This is all thanks to you guys for watching my videos and supporting the channel, so thank you so much. And if you're not already, consider subscribing. We are super close to 1 million subscribers. Hopefully this video will push it over the edge. These cuts almost go all the way through the wood, and they allow me to bend this piece along the saw curves. And as you might expect, that very thin layer of wood that's holding everything together is extremely easy to break if you're not careful. The idea of kerf bending is you fill the kerfs with wood glue and bend the piece around a form, which creates the illusion of a solid curved piece of wood, or in my case, a full ring.
What the heck? I measured it and checked it multiple times, but somehow it's too short. Dang it.
I have no idea how this happened because I physically rolled the form on top of my stock to measure the circumference. Cut it right at that point so there was no math error. If you can see what I did wrong, please let me know in the comments because I am baffled. Anyways, I made enough silly mistakes at this point that I bought plenty of extra wood, so for the other rings, I wasn't taking any chances. I dry fit the pieces around the form and cut right where the edges met, which theoretically should give me exactly the same result as how I did it before, but I don't know. Looking at it now, maybe there's enough imperfections in the bend that it cumulatively adds up to like a 4-inch gap somehow. I don't know, that doesn't make any sense to me, but anyways, we got it in the end. Perfect ring, so satisfying, and now it was time to start cleaning these up. The inside faces were covered with dried glue, but the spindle sander made quick work of this, and it was so satisfying to get these nice and smooth, but I don't really like how the edges look, so I decided to make solid wood rings to act as a face frame. Unfortunately, I didn't have any pieces wide enough to cut out full rings, but I was able to cut out half rings, and these were way too thick, so I ran over to my local hack space and used the bandsaw to cut them in half, which worked great, but they were not a consistent thickness, and the finish was pretty rough, so I stuck them to my CNC table, threw in a surfacing bit, and just manually jogged the spindle over the ring like a giant Etch-a-Sketch, and this worked so well.
The hardest part of this is my left arm's getting tired holding up at the screen.
Figuring out little solutions like this, it's one of my favorite parts of making stuff, and lucky for me, there was gonna be lots more problem solving once I got to the mechanical parts of the door, but for now, you can kind of start to see this steampunk nautical aesthetic come to life. These fan holders were inspired by the portholes on a ship. In fact, when I was searching for inspiration, I went to some antique stores, actually found some real brass portholes that were salvaged from old boats, but this big one is like $1,200. I also wanted a real vintage hand wheel as the centerpiece of the door. Definitely got some inspiration from Colin Furs, and I searched flea markets, more antique stores, but these old wheels were the closest thing I could find, but they don't really have the style of those old hand wheels. Eventually, one owner of an antique store, he filled me in on the reality that these old hand wheels are extremely popular, and in a city like Vancouver where lots of movies are filmed, they tend to get snatched up by prop departments. You stick one of these on a big hunk of metal and it just screams old machinery, which is precisely why I wanted one. So in the end, my search for antiques was a complete failure, but kind of a blessing in disguise because instead of buying something that was 70% right, it allowed me to make something that was 100% right.
Look at the size of this thing.
I 3D printed the hand wheel out of ASA on my Bamboo Lab H2S. ASA is a really cool material. It's super durable, resistant to UV light. It's related to ABS, which is used to make a lot of the strong functional parts you see in your everyday life. It also has this really cool ability to be welded to itself with acetone by slightly melting the plastic.
This thing is beefy. I don't think I need to be worried about strength. This is like, you could drive a car with this thing.
You can use the same property to smooth the print by putting it in a container with some acetone and a fan to circulate the vapors. This was the first time I've tried vapor smoothing, and I was so excited to get a perfectly smooth part with zero sanding.
Well, it's been 30, 45 minutes. It smells like a nail salon in here, but the part looks exactly the same.
I remembered from high school chemistry that a lot of these reactions are temperature sensitive, and sure enough, my relatively cold garage wasn't helping, so I cranked up the heat, put the bin closer to the heater. Anyways, a few hours later, the hand wheel was finally starting to get shiny, which meant that there was a thin layer of melted plastic on the surface, but I had a feeling this bin was just too big. Maybe the air wasn't getting saturated enough with acetone vapors. So I put it in a smaller bin, left it for half a day, and finally this thing was glossy smooth. Ironically, I had to destroy that beautiful glossy finish with some light sanding to prep the piece for paint, but the acetone smoothing completely removed any visible layer lines, so when I hit it with the first coat of primer, you can't even tell that this thing is 3D printed. The primer did reveal some gaps between the two halves, but this was an easy fix with a little bit of Bondo, more sanding, more primer, and it was time to give this thing some color. Of course, I had to go with red. To me, that just screams big nautical valve handle. And this thing looks so sick after just one coat of paint. This is how it looks after 3 coats of paint and 2 coats of a protective clear finish. And right here, I'm threading the handle onto a piece of steel pipe, which will act as the shaft. I made that hole slightly undersized so the metal threads bite into the plastic, and just before this, I cut a keyway into the pipe. You can see a matching keyway in the handle, which accepts a little piece of 1/4-inch steel rod, and this allows the handle to drive the entire shaft. But immediately, I realized this wouldn't work with a hollow pipe, so I whipped up this quick 3D printed filler piece, which worked like a charm. We'll cover up that ugliness later on, but while the sun was still shining, I primed the fans and started painting them with this really cool hammered copper spray paint. I felt like copper was going to look incredible next to the rich Douglas fir, so I also designed these vintage-inspired fan mounts to match the hand wheel, and I 3D printed these on my Bamboo Lab H2D from this copper metal PLA. Now, Bamboo Lab is the sponsor of this video, but honestly, I would be using these machines regardless. When I'm building these super custom woodworking projects, having the ability to quickly create whatever weird specific parts I need is absolutely key to my process, and Bamboo Lab machines make this workflow seamless. I use the Bamboo H2D in laser mode to make these tiny laser cut plywood dovetails, which act as hidden joinery for the big center ring. That's gonna frame the planetary gear set, and it will be a key part of the secret locking mechanism. I cut out the ring pieces on my CNC, but honestly, a laser cutter is way better for tiny precise pieces like these dovetails. You also might be wondering why I didn't kerf bend this ring like I did for the fan rings. Well, kerf bending is optimized for a nice outer face, but this ring is mostly going to be visible from the end and the inside, so I really wanted solid wood that I could sand as much as I wanted. I probably should have made the fan rings in this way for the exact same reasons, but hey, it was a learning experience, and in the end they cleaned up nicely. All the ugly parts are pretty much invisible, and it is finally time to cut some giant holes out of the door so we can get these rings in place.
I'm not sure if you'll be able to see this, but the door is a little warped. It bends upwards slightly. It's like a positive U.
I had put off this operation for days. I only had one shot to make these holes, and they had to be perfectly aligned, just the right size, and this warpage only complicated things. It's kind of to be expected. Solid wood is great, but it likes to move, so I slowly worked my way around the door, adding clamps and bracing. I realized that holding the door down was only half the solution. I also needed to stop it from sliding side to side while the router bit is dragging through the material, and clamps only do so much. A great easy solution to this is just to butt pieces of scrap wood up against the edge and screw them to the wasteboard, and before I knew it, I was kind of ready to make this extremely nerve-wracking cut.
I really don't want to destroy this thing.
And before long, I had a manhole-sized cutout, bang on, right in the center. When you're dreading something like this, but you just carefully prepare and it goes perfectly, such an amazing feeling. But an even better feeling was test fitting the rings, which slid into place.
And then this should go in here with plenty of room to spare. Oh yeah. Oh yeah. It's actually gonna go like this, but we have to go from the back. But that's good for now. We can continue cutting up this door.
While I had the door up on the CNC, I was making every cut I could. I was not risking taking it off, putting it on again, and losing my alignment. So we're doing everything. That includes the hole for the hand wheel, as well as the pockets for the accent pieces and the solid wood fan switches. These switches, which will come from this beautiful piece of old growth Douglas fir, they're one of my favorite parts of this entire project. This ended up being a pretty involved side quest. I'm still really new to 3D carving, and if you follow me on Instagram, you might remember me complaining about how Fusion just did not want to cooperate with this toolpath, but figured it out in the end. It wasn't difficult, it's just like a lot of making. It just takes time and a little patience to experiment. And check out that insanely tight, wavy end grain. This old growth Douglas fir came from some huge beams given to me by Jenna Phipps, another Vancouver area YouTuber. This came from the old house that she's renovating, and I just want to give you a little preview of the finish. Check out how dark this old growth wood gets compared to the newer stuff that I got from a lumberyard. Now, all of those curved pieces you're seeing, those are gonna form a frame around the center ring. I cut those out of one of my fresh pieces of Douglas fir, but you might have also noticed these spoke cutouts.
That's so cool.
And I made those pieces from more of the old growth fir. And as the door starts to come together, just look at how much tighter this grain is than the newer wood. This will become much more obvious once I finish the wood, but first, I spent an hour painstakingly sanding every single scallop in the door, because even though they might look smooth, when you shine light on the surface from an angle, you can see that the surface is relatively rough. But once that was done, I finished everything with Danish oil, and I found that a big syringe was a really good method for getting finish in all the scallops. This was my first time using Danish oil, and it seems pretty great. It's one of the safer finishes to work with, and like a lot of oils, it's pretty easy to apply. I did 2 coats over 2 days, buffing with steel wool in between, lots of buffing with a microfiber cloth, and very happy with how this looks. Although those scallops will really pop once the door is vertical and they're lit from an angle. And just in time for a drastic haircut, the door was ready to start getting put together. I really shot myself in the foot with this haircut timing. You're gonna see continuity errors all over the place, but it was time. Before installing the fans, I was just so excited to see the centering in place, so I gave the edge a quick bevel to help with the fit, and this thing looks so sick.
Still gotta get the frame pieces around them, but that's so cool.
Before we get that installed, those 3D printed fan mounts are gonna get LED strips to backlight the fans. I'm a huge fan of these warm LED strips. I've been using them on a lot of my projects recently. The LEDs are super tightly packed, so they're almost like neon, and I'll link them in the description along with everything else I'm using in this project. I just copied the whole pattern from the original casing of these fans onto my 3D printed mounts, got the fan blades installed, and they fit perfectly inside the wooden rings.
Woo! No rubbing!
Now, one reason I chose these fans is that they are reversible. The original casing has this really cool built-in 3-way switch.
So you pull this cord once, which lines this contact up with one contact, and then you pull it again. Now we're attached to the other contacts.
But this switch is built into the case, which I'm replacing. So I figured out the wiring, picked up this 3-way rotary switch.
If I did this right, if I flick this switch to 1, it should go backwards. Nice. And if I flick it to 2, it should go forwards. Yeah!
This is what I want to control with my fancy wooden knobs, but to get that to work, I designed and 3D printed these interface pieces. One of these gets screwed onto the knob, and the other one gets attached to this tiny square shaft on the switch, and the magnets allow me to hide all of that without permanently gluing anything in place. Everything's held together with screws, so I can take it all apart and replace any of the components.
Oh, that is so satisfying.
Got all the wires connected, and it was time for the first test.
Yeah! So those are now both blowing towards the camera. If I go both backwards, now they're both sucking air, blowing it that way, and we can stagger them. So now it's circulating the air, yeah!
Now, if you think that all the time I'm spending on these elaborate fans is just a ploy to procrastinate on the intimidating work of actually building the mechanical parts of the door, you would be right. But I think this procrastination was kind of necessary. Getting this really satisfying work done, seeing the door start to come to life, it gave me the gumption I needed to start tackling the parts of the project that I was less confident about. And I was gonna need all the gumption I could get, because after cutting out the wooden gears, which would eventually come together into 3 layers, I just threw one of the layers together using some parts from the prototype.
All right, so I'm not really sure why, but these gears, these are the exact same gears as my test, except they're cut out of 1/2 inch and they have all the intricacies in the middle. Hooked it up to the test rig, and it is a lot tighter than the 1/4 inch test gears.
I was so confused in the moment because, like I said, these are exactly the same dimensions as my prototype, which spun like a top. This seemed like it should spin super well the same way. I didn't know what to do, so I just started sanding down the teeth with a Dremel, and after an hour of that, I thought, hey, maybe that was enough. So I assembled the gear set, which includes a spacer in the center that locks all of the gears into place so they don't just flop out to the sides.
So, turns out, you wouldn't believe this, but wooden gears have a lot of friction, especially when it's 3 layers of plywood. It's not, I think it's gonna work, but I also see why people usually make gears out of like metal or plastic. I don't know if I can even get it to rotate here. Like as I use it, it gets more broken in. Oh yeah, there we go. So
So it does rotate, just not well, and I was worried that this would make for, at best, a terrible user experience, and at worst, the force of rotation would just snap the plastic hand wheel. But dry fitting the gear set was actually a really helpful exercise. I suddenly understood why this was happening now and not with the thinner gears. Thicker plywood means way more surface area at the teeth, which means more friction, especially when you double the gears. But this problem could be solved pretty simply by just beveling the teeth. You now have effectively thinner material where it matters, and I realized that a lot of manufactured gears have these bevels for this exact reason. I whipped up this quick test handle so I could actually turn the gear set from the sun gear like it will be in the final door.
Woohoo! Oh yeah! All right, that sanding made a huge difference. Let's go.
You can see here just how much mechanical advantage you get from the sun gear, and even rotating the planet gears was so much better, but I was gonna need a better way to drive the sun gear. That hole was originally sized for this bearing, but I quickly realized you can't drive a gear with a bearing. The shaft will just free spin. So I cut out these discs, which accept a 1/2-inch threaded rod and another 1/4-inch key, just glued those in place, and it was time for paint. To be honest, I was still pretty nervous about the gears, specifically that the handwheel would just explode from the force of rotation. So I did give the gears another heavy sanding, and I was kinda hoping that the paint would somehow improve the motion. Maybe a smoother surface would have less friction. We'll find out in a bit, but while the paint was drying, it was time to build the secret locking mechanism. There are 11 spokes that surround the center ring, and 9 of those spokes will have knobs that are purely decorative, but 2 of those knobs will move and move mechanisms behind the door. I'm just gonna leave those empty for now while I glue in the frame pieces. I feel like this double-layered frame really takes this part of the door to the next level. I just love all of the layers, and you know I had to see how that was gonna look with the center ring.
Lovely. Now, to actually allow this to do stuff, gonna need to cut out some of this plywood ring and replace it with some 3D printed pieces.
Throughout this project, I was having this strange internal struggle. I felt guilty that I didn't finish designing the door before I started building it. Stuff like this, that janky mending plate situation, that's a direct result of designing and building on the fly.
Looking at the back of the door, and you might have noticed all of these little holes.
I don't know where that guilt comes from exactly. I think there's some perfectionism there, some assumption about how things should be designed, especially as an engineer. But the fact is, after my last secret door project, I was just so sick of sitting in front of my computer for hours and trying to design everything up front, which for stuff like this, that might actually be the wrong way to do it, because this designing on the fly thing was actually working extremely well. And I was having so much fun running between the basement and garage, whipping up little 3D printed pieces as I needed them, like this gear, which will slide onto the shaft of the hand wheel and allow the center ring to lock the hand wheel in place.
Oh yeah! Woohoo! Damn, that is smooth.
Sorry to interrupt one of the best courses of all time, but I have to talk about this little latch, which was a pretty big engineering challenge. I included space for a square nut and a grub screw so I could lock the knob in the correct position in relation to the latch. If I didn't, it would just free spin in that nut, but it wasn't working. I could still force the knob past closed without much effort, and when I took off the latch, I found the problem.
So I think that square nut is being held in place by this really thin section of plastic, and you can see it was actually getting pulled out as I was tightening the grub screw.
So I designed a version 2 which reinforces that area.
You can see I had to cut away a little bit of this to get it to fit, but that's all right, and check it out.
It seemed to be working better, but if I forced it, I could still overturn the knob.
I'll just tell Eden not to force anything.
Yeah, no way I'm giving Eden a subpar secret door to solve with a bunch of disclaimers. We'll figure this out, but it was going to take the work of building the rest of the mechanisms to finally show me the best elegant solution. This will be the mechanism for a hidden light switch. I knew I wanted one of the knobs to twist and turn on the lights, so I got one of these twisty lamp switches, but it felt really loose and imprecise. There was no way I was going to be able to align the knob in the correct orientation, so I went in my electronics cabinet and dug out one of these beefy switches. This switch feels much more precise than the twisty lamp switch, but the motion is all wrong. It's linear instead of circular. Well, luckily, the problem of converting circular motion into linear motion has been solved for about 500 years. Enter the rack and pinion. If you watch my video about the secret door for the library on my stairs, this might look a little familiar. I did steal part of this design from that switch, and this is so satisfying. I could play with this for hours, but after a few days of drying, the paint on the planetary gears was fully cured, so it was finally time to get these installed. Now from this point on, you're gonna see a lot of these 3D printed standoffs because many of the parts have to be mounted with very precise gaps. Just another way that 3D printing is such a great tool for these super custom woodworking projects. Now, if you remember, my major fear with these planetary gears is that they're just gonna be too tight to drive with a plastic hand wheel, and things were not looking great. It was a bit of a struggle to get the sun gear in place, but we'll find out for certain once I add the drive shaft.
You ready for this? We got ourselves a working wooden planetary gear set. Yeah. It is not smooth. It's pretty tight, but it's working. I just got vice grips on the back, and we're gonna get even more mechanical advantage through the bike gearing.
Oh yeah, I forgot to mention, I bought a $20 bike on Facebook Marketplace to cannibalize. We'll get to that very soon, but first, I wanted to replace the plywood planetary carrier with a solid piece of acrylic. This will hide what's behind the door while capturing all of the light from this ring that I built. It's gonna create this awesome backlight effect, and to help distribute the light, I also cut out some pieces of MDF, glued on tin foil, and attached those to the ring to act as a reflector. It's so cool how the acrylic hides how the gear set is actually driven. And since the acrylic is attached to the planet gears, it rotates with them, and it will provide a mounting point for the part of the mechanism that will actually lock and unlock the door.
We got our light ring, and I was originally planning to mount it about an inch off the back. And that's what it looks like, which is pretty cool, but it's sort of edge lighting the acrylic. And as I pull it back, more of that light hits it straight on, and it looks way better. Luckily, we have extra room on these rods. We're not gonna run out of space, so it's kind of all good.
To create that big gap and support the ring, I picked up some long, beefy lag bolts and made more of those custom 3D printed standoffs.
Time to finally cut these short.
With the planetary gear set fully operational, it was finally time to link it to the hand wheel. And to do this, I'm gonna use parts cannibalized from that old bicycle, specifically the chain and the sprockets.
Hey! That's what we need.
These were very rusty, so I soaked them in Evaporust for like a week, which worked extremely well, and I chose the biggest and smallest sprockets that I could salvage so I could get as much mechanical advantage as possible and minimize the chances of the hand wheel snapping under the resistance of driving these wooden gears. Once again, huge shout out to Bamboo Lab for sponsoring this video and making 3D printers that are so easy to use that I can seamlessly design parts on the fly. You might be surprised to find out that I just printed these sprocket holders from PLA, which is the most common 3D printing material, but it's actually really strong, especially if you print extremely dense like I did here. And since these will be carrying a lot of force, I realized that I could actually use 2 set screws to really lock them in place on the shaft. And of course, I've now learned that I really have to bulk up the area around the square nuts. With that, I was pretty much ready to link the two shafts with the chain, but I don't really do a lot of bicycle mods. This was actually the first time I've ever used one of these tools to resize a chain, and I was a little disappointed to find out that getting the exact right length was going to be impossible, which is kind of obvious in hindsight. So I ordered one of these chain tensioners, and while I was waiting for that to arrive, I wanted to make moves to get this thing hung in the basement ASAP. So I carefully reproduced the hinge pattern from the existing door, mortised those out with my router, and blitzed through some finishing touches to take advantage of this thing still being in the relative space and luxury of my garage. Finally got those 3D printed fan grates installed. I'm so stoked to see how these will catch the light of the LED strips. And to power all the LEDs, I picked up a 12-volt power supply and designed this simple 3D printed mount. I love this song so much, had to run it back one more time while I'm doing some last-minute cable management on the door. 3 LED circuits controlled by a single switch, power supply, 2 separate switch fans. This ended up being a lot of wires, so this hour of routing cables was well worth it, and just in time for my friend Rob to come over and help me bring the door down to my office. Now, even though I made the door the exact same size as the original, there was still a part of me that was dreading the possibility of this thing not fitting in some strange, unexpected way. But after some finagling, we finally got all the screws in place and...
Wow, that is insane. You want to see it from this side? Whoa.
It's 20 seconds till the last call. Go ahead.
All right, so I got the power bar, and check this out. You ready? Honestly, I didn't even think about the fact that this is in a basement, so having it feel like a submarine door is kind of sick. Woo!
It's not a miracle we need it. And no, I wouldn't
Yeah, buddy.
so.
You ready for this? Not that, but that's pretty cool.
This was huge. Instantly, all of my worries about the planetary gears just disappeared, and then...
Oh, chain just fell off. I think I might need to 3D print some sort of chain guard or something, but it was working for a second.
A chain guard was not going to fix this problem, which seemed to be that the chain was slipping off of the sprockets when I reversed the direction of spin. That would cause the chain tensioner to move away and, well, lose all the tension.
Oh, no.
Yeah, so it's gonna stick to the gear because there's not an tension anymore, yeah.
As I was tinkering with the drivetrain, I noticed that the tensioner wasn't quite in line with the sprockets, which probably wasn't helping, so...
I added some washers to improve the spacing, and I don't know if you can see that, but it's not slipping. We are rotating, the chain is staying on. The problem, I think, is when we go in the other direction. And oh, I can see, yeah, and the chain just slipped off. I've never done stuff with bike chains before, so my beginner brain was thinking, well, I just need tension on the other side too. So I basically bought a second one of these, and it hasn't arrived yet, but I'm just gonna plan on pushing on the other side of the chain as well. What do you think about that plan? Do you think I should do something else?
Do I think it's gonna work? No.
All right, Brendan. Well, I think it's gonna work, but I guess we'll find out when the tensioner arrives in 2 days. In the meantime, I finally began work on the door latch, which might seem a little late considering this is what will actually lock the door closed. I'm using a piece of flat bar to latch the door, and that slides right into the existing strike plate. Once again, the 40-watt laser attachment on the Bamboo H2 series coming in clutch to make a bell crank. This is a classic mechanism used to change the direction of linear motion by 90 degrees. That will be mounted to the door through the center pivot. Just gotta drill a quick hole for a threaded insert.
Oh no! Shoot! Oh, nice. Very nice and obvious.
Yep, that's frustrating, but the nice thing about Danish oil, and I think most oil finishes, is that you can cut out a plug. Cut out a plug, glue it in place, match the carving, little sandy sand, and it's really easy to refinish. Pretty much unnoticeable in the end.
There you go. I feel like you can't even see that.
As I was saying, the center pivot is getting attached to the door through this threaded insert, and this thin piece of plywood is just a prototype. The great thing about the laser cutter is you can make prototypes like these extremely fast, learn from your mistakes, and iterate. Now, I was going to need a track for the latch so it would only move horizontally, and while I was printing on the H2S, I whipped up a simple router template so I could carve out this recess. This will provide space for some bolts that hold the sections of the latch together. I know this all might be a little confusing. It will all make sense in a moment. So here is our assembled bell crank prototype, and you can see now why we need that recess, although I definitely made it unnecessary long, and why we need a track. The prototype seemed to be working, but the crank was way too flimsy, so I cut out 6 layers of plywood, glued those together, and reassembled everything. This time I used washers to make sure that everything was aligned, and I locked everything in place with nylon lock nuts. And this is all driven by that acrylic disc, which moves with the planetary gears.
Oh, dude, this is so cool. I think with that second chain tensioner, also, it sounds so mechanical. Let me just put the mic right up there so you can hear.
I could do this all day, but Eden was gonna be home any minute, so I quickly threw a curtain over the door so she wouldn't get any hints. How do you feel about the curtain?
I feel fine. It was a black curtain. I have no feelings associated with it.
Nice, perfect smoke screen, and after a good night's sleep, I finally figured out how to stop the secret latch from slipping. The whole double set screw thing that I did with the sprocket holders, I could use that here too.
The latching mechanism is working beautifully. I cannot be more happy with how this is going, but unfortunately, because the bell crank reverses the direction of rotation, I can't use the secret lock anymore. This is extremely difficult to explain, but basically, I can only now lock the mechanism, like lock the latch, I guess I should say, when the door is unlocked. So I can use the secret lock in this position, but I can't use it in this position, which is like the opposite of what I wanted.
But you know, sometimes it just takes saying the problem out loud to figure out the solution. If the problem was that the secret latching mechanism moves in the exact opposite direction from what I need, theoretically, I should be able to fix it by just flipping around these 3D printed pieces. This only works because these ring pieces are symmetric front to back, unlike the latch, which doesn't have any symmetry, so I just had to mirror that in the slicer and printed a new one. Now, this was all theoretical, and I was all ready to test my theory until I got a notification that the second chain tensioner had finally arrived. So I guess we're testing everything at once because I was stoked to get this installed and stop the chain from randomly popping off. And it seemed to be working. I should probably mention that I totally took Brendan out of context when he said that this wouldn't work.
The problem is then you have slop in the whole mechanism because then as you start to turn, instead of rotating, you're first going to be preloading the spring and those tensioners, right? Like, you know, slopping those two things back and forth. I just mean when you start to turn it, the first little bit of turning is going to be going into tensioning that spring in either direction rather than rotating the mechanism. Which
Right.
I guess if you don't care, then it doesn't matter, but...
And kudos to Brendan because that's exactly what happened. And he's right, I don't care about a little slop. It actually makes the door a little more fun to operate. But after a few minutes of testing, I guess we hadn't solved the problem. So I tinkered around, added a couple of washers to line everything up a bit better, but then I noticed.
So I want this one to stay like down here, but as much as I tighten this, it's still a pivot, so when the tension lets off, it inevitably gets pulled back up here.
So I threw that Allen key in my vise, chopped off a couple pieces, laser cut a bracket, glued the stubs in place with some 5-minute epoxy, and used those makeshift brackets to lock both chain tensioners in place. This still allows the springs to move, but it prevents the tensioners from gradually pivoting away from the chain, losing all that tension.
Uh-oh. Oh no. Am I locked out?
Anyways, at this point, I'd fixed the mechanism so many times that it didn't take me long to figure out the new problem, which was the hand wheel. Since the shaft is only supported from this bearing, the weight of the hand wheel was pulling the entire shaft down and to the left, which was messing with the alignment.
It'd be great if we could also put a bearing in from that side. Unfortunately, I found this bearing at my hackspace. I have no idea what it is, and I'm revealing the door to Eden tonight, so
I had to figure out something fast, and you might remember this 3D printed spacer that's on the shaft. Well, if I just redesign that to extend into the hole in the door with just enough space so that it supports the shaft without being too tight, that might do the trick.
Oh yeah, she's locked in now. Dude, it is so much better. The chain isn't derailing at all now. It's working so good now.
And with Eden coming home from work in just 2 hours, it was a sprint to add the finishing touches. First, I made these 3D printed covers to hide the shaft at the end of the sun gear, as well as clean up the centers of the planetary gears. And finally, to actually lock the door, you have to engage the center ring with the hand wheel at exactly the right moment. That allows the secret latch to fall into place when the door is fully locked. If you engage the center ring too early or too late in the movement, the secret latch will be in the wrong spot when the door is locked.
Okay, I think I figured out a good solution. So what I've done, we lock the door, and when those two pieces of tape align, that signifies that the door is fully latched. When these teeth aligned here, you see those other two green teeth? That is exactly the point when I want to engage the outer ring. We engage it, now they're both moving until the L, and then there we go.
And perhaps more importantly, this works in reverse, so you can use the secret latch to unlock the door. The only thing left to do was replace those pieces of tape with some dots of paint. I chose red and green, subtle yet instantly recognizable symbols for stop and go.
All right, now is your chance to tell me if you actually saw any parts of the door.
I didn't. Well, okay, I saw like a big 3D printed wheel thing,
Okay.
but I knew you were making like gears and wheels. I don't think that's gonna help me.
What
at all.
color was it when you saw it?
Like gold, like bronze?
If you could give like a few adjectives, a few vibes of what you think it's gonna look like, what would you say?
Impressive. Opulent. Like I feel like the front of the door is gonna give like old money vibes.
All right, let's go see.
Yeah.
All right, wait, stop. I'm like really nervous. Eden hasn't seen any of this. I have no idea what her reaction is gonna be. I have no idea if she's gonna instantly be able to solve it. All right, you can come down.
Okay. I was wrong. I was kind of right. I was wrong right. Whoa, this is so cool. It's like a ship. Wow. Wow, whoa, this is beautiful. Now I have to open it.
Now you have to figure out how to get inside.
Okay.
Oh my God, you instantly got it. you got both. Oh wow. You're very smart. That was like maybe 8 seconds.
That's what she said.
Well, I'm happy that I'm an intuitive designer.
After hiding this from Eden for months, it was so fun to finally show her everything I had been working on.
This is gorgeous though. I don't know if I like needed you to design like a bunker that was a fail-safe room. If I would like hire you, I'd want it to be a little bit harder to get into.
And you know, after building a secret door that even I have trouble opening, I think deep down, I always wanted this one to be a little more user-friendly.
But there is still more that I want to add to this door. I'm currently working on some super fun upgrades, as well as some more practical additions. So make sure to subscribe to see part 2. And if you can't wait that long, check out my Patreon where I post behind the scenes videos while I'm building these projects. Special thanks to my top supporters on Patreon, Paige Arlt, my mom, Kathy Kert, and we have a new top supporter, Sawyer, who is 5.5 years old and loves watching my videos with her dad. Sawyer, thank you so much. And you know, you're never too young to start building secret doors. I think you could build one that's even cooler than this one.